So break means just to relax only, guys. Okay, so are I having some tea or kind of something? So we'll start with the topologies. Okay, the devices, the few devices are there. While I'm telling devices, also I will tell small home kind of stuff. Okay, small home, small office kind of stuff. So okay, so topologies. This is a physical topology. There is a two type of topologies are there. One is a physical topology, another one is a logical topologies. Okay. Physical topology. Physical topology. Okay. Physical topology. Physical topology means okay, how physically connected. Okay, how physically connected. It is like a network, not networking. So only we create a network. Physically, we create a network. So physical topologies. So what are the physical topologies? Bus topology, ring topology, mesh topology, star topology, hybrid topology. Very few batches, means last year a few batches asked me what is tree topology. Okay, because I don't know, so that's a tree topology kind of stuff. Okay, as I know there is a few topologies are there, so that is bus topology, ring topology, mesh topology, star topology as a book and as well as a Cisco networking. Okay, hybrid is a mixture of any two topologies, mesh topology, star topologies. Very recently we understand like a point to point. Point to point, this is also you can consider as a physical topology. Okay, point to multi-point. This is also you can consider, but it's really it is not a topology. It's just a understanding purpose on this. Point to point topology, point to multi-point topology is also there. Okay, but important original is this only. So we'll see that one. So one by one. This is a computer or a device, whatever it is. Generally, it is. We think it is a computer. Okay. I have a series of computers, and there is a backbone wire. Okay. There is a backbone wire. Our old days, we have a cable TV, right? So the cable TV guy run a cable from his office through entire street. Only single cable only. And what we do, we connect. The guy will come and you need a connection, so you take main wire and take a connections from main wire to your individual TVs. Similarly, it is also same thing. You take a one backbone wire, from that one you form a T connection and connect it to individual computer. It is very easy. It is very easy to create network. Okay, lesser the cost, no extra devices we don't require. This topology we call it as a bus topology. But there is a little problem. What is the problem? If this background wire broke, automatically communication stopped. Okay, few devices are communicating each other, few devices won't communicate each other. That is bus topology. Next one, I have a devices. Okay. So to avoid that one, so someone build this type of thing. So what is this? I connect my PC to another PC, other PC to another PC, like a side by side. One PC is connected to another PC, other PC is connected to another PC, like this. So finally, last device is connected to the first device, just like it is a closed circuit. This is what happens here. I have to create an algorithm here. So to communicate from A to B or A to C, I want to communicate A to C. Then I have to tell forward a packet to B, B will forward a packet to C. Like that, we have to tell it. You want to communicate A to D, then you have to define path A, B, C, D. Like it, that is the path. Okay. So till reach the destination. Okay. B want to send a packet to E, C, D, E, like this. So what happens here when you are communicating like a B to C, then C to D, then E to D. So if it is a bigger circuit, then it is will take a lot of time. Okay. So what they done to avoid that confusion, they added a extra one more ring like this. Again A to B, C, B to C, C to D, D to E, E to A. But this is double time is there, no? So it is a clockwise and anti-clockwise it will work. Okay, it will work clockwise and a anti-clockwise. Means for one is like a to B, B to C, C to D, and D to E, E to A. Next one is anti-clockwise, A to E, E to D, D to C, C to B, B to A. Okay, so there's a two connections. So why two connections? Why double ring is required? So the double ring is for if in case if line is broken, if line is broken or device is down, still you can able to communicate other devices. Okay, still you can able to communicate other devices. Just I'm removing that single ring. Again, so A send a packet to B. So A will send a packet to B. So I will take a little thick color. See, that is okay. But A want to send a packet to D. A to D. Now again, A has to send a packet to B. B send a packet to C. C send a packet to D. So this is how it is communicate finally. If in case your CPC is down, she can't communicate. Can't communicate even though there is a path AED is there, but it is only one direction type only. Okay, so this is single ring topology. For example, a device is down or a wire is down, so obviously communication will be stopped. This is one way, means either clockwise or anti-clockwise. Now to solve the problem, I put a additional ring to it. This is said, for example, one ring is a clockwise, other ring is anti-clockwise. It means A want to send a message to D, A to D communication. Okay, so either A will send from B, C, D, or it send a packet to A, to E, E to D. So depends upon that algorithm, it will send it. If in case a device is down, still no problem, it choose another path to reach the destination. One second. One second, guys. Okay. Okay. So what is this topology, guys? Anyone? Why people are not at all talking today? Where is ours? Guys, are you able to hear?
Yes, sir.
Yes, sir.
Then okay.
Yes, sir.
Okay. Next one is like this. Anyone will guess what topology it is?
Mesh.
Very good. Mesh topology. Okay. So some people will think, like even myself, I think it is a star topology. Okay. Earlier when we are in engineering, so that time people write thought a very lot of preparation. They put a star because it is a star. They said it is a star topology. Okay. It is not a star topology, guys. It is a mesh topology.
Topology.
Okay. It is not even a complete topology. This the complete will be like this. Very good. Mesh topology. Mesh topology means every device is connected to another device. Every device is connected to other
Another device
device
in network.
in the network. Okay. So this is PCA, PCB, PCC, D. So what is the advantage of connecting like this? For example, if a device is down, no problem, all other devices still communicate. So no dependency. Okay. All other devices will communicate each other. Or a wire is broken, no problem, one way or other way, so people will communicate each other. It is a highly redundant. Redundant means if one device is down, no problem, other device will give you information or do work. Okay. So something like you have a two cables are there. One cable, your system is connected with a cable, two cables. Okay, one connection is down, no problem. You have another connection to communicate. That is like a redundancy. Okay, just like that one. So having a multiple ways or multiple things. That is a redundancy, duplicating things, redundancy. Okay. If one is lost, no problem. In other way, we will get it. So like that, it is kind of stuff. Okay, that is called redundancy. Again, we'll go back to the mesh topology. The mesh topology is highly redundant. So every device is connected to all other devices. All other devices. So this is called a mesh topology. So what is the fault in this one? So it is a highly redundant and can stuff. The problem is if you are bigger the network, complex it is. Cost increases, complexity increases, troubleshooting is very difficult. For example, I got a new PCF. Okay, so new PC is added. Again, I have to go to each and every device and additional network NIC I have to add. I have to put one more NIC here to connect this one. One more NIC to connect here. One more NIC to connect here, like this. Again a wire. See, it is like a clumsiness. It is a more clumsiness here. So what happened? So more complexity, difficult to troubleshoot, difficult to troubleshoot. It is not scalable. Scalable means extending. We can't extend the topology, means more devices. Devices are increasing. So you have to easily add those devices to network, but it is very difficult here. So that is mesh topology. Mesh topology increase redundancy. Redundancy is there, failure is there, but remaining are difficult. So that's why we don't use mesh topology also in our basic networking. Mesh topology used at a server side, SAN storages, or a server related kind of stuff, or a core networking places, like ISP provider, core networking. They use mesh topologies because redundancy is important there. In our network, we don't use that kind of stuff. Okay. Next, this is we already discussed. That is, we have a centralized device. Okay. And there is a devices, means our computers. Okay, devices connected to a centralized device. Diagrammatically, it is look like a star. Like a star will glow, right? So like brightness of the star, like a sun is a star, right? So like it is, the light will draw in kind of stuff. So like that, it is diagrammatically is there. So it is called as a star topology. Star topologies. Okay. So here you have a computers A, B, C, B, C, D, E, F, like this. So everything is communicating each other through the centralized device. The central device can be hub or a switch. Central device can be hub or a switch. Okay. So what is the use of this one? So no need to create algorithms. No need to program it each and every device how to communicate. That is not required. That is in the ring, like a ring topologies. No need to depends upon the backbone wire, even though it is like more traffic and collisions are there. Okay, it will take a lot of time to reach the destination in a bus topologies. No complexity compared to other topologies. No complexity. Okay, complexity is less. Little costlier. Why? Because of we are using a device extra. All others we don't use extra devices. We have our computers and wires only. But here it is the centralized device we are using. Centralized device we are using, like a switch or a hub. It does not mean costlier. So compared to other things we can consider. Okay, so lesser complexity, easy configuration, no redundancy. Redundancy is not there, but scalability is there. Redundancy is not there. Scalability is there. Okay. Here also same thing, like if one of the device is down or a wire is broken, no problem. Still other devices will communicate each other. It won't affect on a other device communication. If the centralized device is down, total communication will stop. Total communication is stop. But how it is easy to troubleshoot? Immediately you can understand, is a centralized device problem or a wire problem or a device problem? We can easily understand by looking at. Okay, so this is our start topologies. I said we can able to extend. I said already we can able to extend, means it is a scalable. If you take another star topology, okay, and if you connect the devices one to another one like this switch and this switch is connected, this switch and this switch is connected, obviously okay, so this switch and switch is connected, obviously it's like is an extended one. It means, you know, the switch contains, for example, 24 ports are there. A switch contains 24 ports, but I have a 40 devices, 40 computers are there. What to do? I took a two switches, 24 plus 24, totally 48 ports are there. So 48 computers I can able to connect it. Understand, guys? Take example. I have a 40 computers, but I have a 24 port switch only. I can't connect it, right? 40 devices I can't connect it. So what I have to do? I take another 24 port switch and make it connected, and I can totally 48, means almost like a 47, 46 computers I can able to connect it. Okay, so this is the extended star. The second part, what we said is extended star. Single star topology and another single star topology combined and become a single network. So that is called a extended star. So as I said, bus topology, ring topology, mesh topology, like that. So of course, there is a hybrid topology is also there. Hybrid is everywhere. We'll see that one. So point-to-point topologies. Point-to-point topology means if you connect a device to another device, okay, like a PC is connected to a switch, or PC is connected to another PC, a router is connected to another router. So that is a point to point, means a device is connected to another device. This is a point to point. This is also point to point. B2B point to point. This APC to switch point to point. Sir. Okay. Point to point topology means it can be any device to any device. Okay. A PC to a switch to switch, or a router to router, PC to PC, anything, any device to any device. Okay, that is point to point. Point to multi-point. For example, you have a router and your router is connected to multiple routers. Okay, one single router is connected to multiple routers. This is a symbolic representation, or you can say point to multi-point. Switch is connected to multiple devices. That is also point to multi-point. So one device is connected to multiple device type. This is a point to multi-point. Okay, point to multi-point. So this is bus topology, ring topology, mesh topology, star topologies. The remaining topologies are just in a different ways are there, but to understand only point to point topology means simply one device is connected to another device. This is like router to router, switch to switch, PC to switch, PC to switch. That is a point to point. And comes to the hybrid. When it is, we can say a hybrid. See, it is a point to point plus. You can see this one. This is the point to point topology plus it is a switch star topology. Like that, it is hybrid will come in. Okay, so that is nonsense, but I will tell two more points. It is batch 17. I'll take another paint for explaining that one. I'm not typing anything, guys. Just I'm explaining how the topologies are there. Name of topologies. That's it. Look at here. This is a star topology. Okay, what is star topology? All devices are connected to centralized device to switch or a hub. We are connecting all the devices, all computers are connected to switch or hub. That is a star topology. That is star topology. So we have a star topology. And also, what is mesh topology? Every device is connected to every other device. Every device is connected to every other device. Like this. Okay. So maybe like this. It is more clumsy. Okay. Okay. So like this. If you are combined two different type of topologies, so you can also call it as a hybrid topology. So full mesh topology means star topology plus mesh topology. You can create a full mesh topology. Next, I told no last time people are asked a tree topology. It's a really there is no tree topology kind of stuff. But in a core topology means I have a for example routers are there or a big switches are there. I am distributing this network to multiple networks. Okay, so this is a main connection routers, and there is a RS switches or routers we can say, and I'm distributing network. So multiple layer of networks are there. Okay, so layer wise network only. So some people put a name on it that is called a tree type. Okay, meaning is one core router or a switch is connected to distribution layer core or distribution layer switches or routers. Okay, and distribution is connected to access layer. Access layer, guys, remember access layer meaning is, so I have a router in my premises, customer premises unit, CPE. What is CPE? Customer premises unit. That is comes under access layer. Access layer. So what is distribution layer? Is a connecting multiple this access layer into one unit, one location. For example, I'm getting internet. My router is not directly connected to ISP provider. There will be a nearest router will be there. Okay, okay, nearest router will be there. So that is connected here. Okay, and these distribution layers will connected to any of the core layers. Okay, so this is a called a tree topology. But in a really there is a directed tree topology I never seen in a Cisco textbook. Okay, because of yeah, from 2007 onwards, I know that is Cisco networking related one. Okay, up to till recently also. Okay, that is tree topologies, PAN communication, hand communication. Maybe for a very new generation they put it something, but it's not a new one, not a old one. The people are putting in names, but tree topologies like that. Core routers is connected to distribution router connected to customer premises or a access layer routers. So this is how it is. But these are the main topologies: bus topology, ring topology, mesh topologies. Okay, so you go to the bus topology. Simply you can write like, what is bus topology? Devices are a computer. Devices connected to a backbone wire. Okay, it is easy to configure. If backbone wire broke, right? So BRO broken, no further communication. Some lines already it is there in a PPT also, so you can go through PPT. There it is something like this. Okay, including diagrams also there. Okay. So you can go to the PPT. Ring topology. So simply two lines I am trying to say this. A device or a computer connected to next device, or you can say each device connected to next device. Okay, last of the line, last device connected to first device. Last device is connected to the first device to form a ring. We define communication path by algorithm. One second, why I am not able to type algorithm? That is correct only. E is extra algorithm. Okay, if any device down or wire or disconnected or wire broken, no further communication. Okay, that is ring topologies. What is mesh topology? What is mesh topology? Each and every device connected together. How to tell? Each device is connected all other devices. That is very good. Each device connected
to other devices.
all other devices. Correct. Very good. Correct. All other devices. Okay.
If network is large, then complexity increases.
One point I will add, and then I will add that one. Okay. So redundant. So if redundant, the meaning is if a device or connection down, still we can able to communicate. What I'm typing. Okay. other devices. So that is redundant. Because it is complex, difficult to troubleshoot, no scalable. Difficult, scalable, difficult to scalable. So this is mesh topology, ring topology, mesh topology. Last one is topology. What is star topology? All devices connected to
Central device.
Example, hub or a switch. Now it is very easy to configure. Easy to configure. Scalable. This
Less
scalable.
complexity.
You can extend network. Yeah, less complex. Less complex.
We don't need
No redundancy. Very good. Easy to troubleshoot.
no need of algorithm.
No need of algorithm. Very good. Okay, no need of algorithms. No redundancy. That is negative point, but still there's a lot of positive points are there. So entire communication depends on central device. Central device stop working. Okay. Total communication stop. Okay, that is a stop topology. So hybrid topology means combination of one topology to another topologies, but point to point. What is point to point topology? A device is connected to other device simply a point to point. For example, router to router, maybe a switch to switch, not only a PC to PC, not only a similar type of devices, also different devices like switch to router. Point to point. A PC to switch. These are also comes under point to point communication. Point to multi-point means a router connected to multiple routers in different geographical location, like a different networks. Okay, simply a device is connected to multiple devices. Or a switch is connected to multiple devices, multiple computers. That all comes under like this. So these are all what we discussed in the topologies. Of course, there is a tree topology is also there. So tree topology is also I explained. Just like I have a network core layer, distribution layer. Okay, access layer. Okay, so like that, it is the form of tree form of network is there, like switches, and all switches are connected to a big switch, and finally it is connected to the routers are a very big layer 3 switches like that. Okay, so for managing to create a very big network, for example, I want to create a, so in our office, in our Pune office, the network is like this, simple to understand. We have a 3-4 rooms are there. Okay, in each room we have a computers. Okay, then we take in a 3 switches are connected like a extended star. Okay, so devices are connected and these switches are also connected each other, and finally I connect a router to this switch. So internet is distributed to every place. So that is also you can consider as a tree or a point to multipoint or an extended star like this. Okay guys, so this is your physical topologies. Next one we'll see the OSA layer. Now take a break, guys. 10 minutes or 15 minutes break.